It was a fantastic course, but I don't know if you remember, there was an interesting moment for me. It happened in your office.
I don't remember this.
It was during office hours.
Good.
When we were doing Galois theory. We were doing Galois theory.
Yeah.
And we were learning about field extensions and how to solve equations and by adding various roots and so on. And you gave us a great problem, and I'd worked hard and come to the answer. Bring out various roots of unity and radicals and so on. And it just struck me, and I came to you and asked you that I said, I've done all this calculation, but I feel like the way that we solve the problem is just by introducing a new symbol that solves the problem. And you thought for a minute and you said, that's sort of right. That's really, in some sense, what it is. At that moment, it just struck me that, well, at least certain mathematics, it just felt like it was just pushing around symbols. And they were important symbols and they meant something, but nevertheless, it was just marks on a page. And then, on the other hand, when you could use those marks on a page to describe the universe, that felt to me so much more compelling. And that was sort of a flip for me, in a sense.
Okay, well, look, there's some high school math student put on the internet a joke. And the joke is so close to one of the deep ideas of Kronecker. Here's the joke, and then I'll tell you the deep ideas of Kronecker. The joke is, it's a piece of a problem, clearly homework problem, says problem 5. Then there's a right-angled triangle, and the two non-hypotenuses are labeled, and there's an X on the hypotenuse. And the text by the X is find X. And you can see the joke. There's a sort of a scrolled pen with an arrow pointing to the X on the hypotenuse. All right. Now, that's one way of viewing the symbol. Kronecker's view is slightly different, but very close. For example, if you want to solve the equation x squared minus 2 equals 0, you might laboriously try to compute this, and you'll discover that it's the square root of 2, and you will discover that it looks like 1.4 if you're thinking of it. Kronecker says the essence of the solution of that equation is that whatever solution it is, x, whatever it is a symbol which has the property that its square is 2. And if you're an algebraist, if you merely use that, that is to say, if you, so to speak, retreat from the content a tiny bit, blind yourself to the content, and you algebraize the situation, you have a symbol, you don't know anything about it, except you know that its square is 2. You will learn much more about that symbol sometimes than if you knew that it was 1.414, etc. There's a literary analogy here in the Russian literary critics. Viktor Shklovsky has a thing that he calls algebraization in literature, and what it is having language retreat from content so as to produce the shape of things. Yeah. At one point he calls it putting the object in a velvet bag so that you see its profile, but you're not blinded to the particulars of the thing. I think that's what I was telling you in office hours.
Right. You should have stayed in mathematics.